In this example, I want to go over a technique that you can use to extract data from a table. If you open up the starting file for this activity, you'll see a table that represents the sales volume given a particular state and given a product. Now I'm zoomed out just to show you the size of the table. This is for an example, of course. You could be in a situation where your tables are much larger than this, which is why this technique is so valuable. We can write a formula to essentially extract the data record we want, and of course that could be used later to build really dynamic spreadsheets. So let's take a look at the example. Let me zoom in a little bit for the sake of the video. The technique that we're going to use requires actually two different functions. One is an index, which will be used to highlight the data and return the specific row and column that we want. So if we're indexing, for example, let me zoom out for this demonstration. If we're indexing, we're going to index this highlighted section of the table. We're going to use another function called match, and match is going to tell us which particular row we want and which particular column we want. So essentially, if we were to look up this particular product, OPTIR, in row 20 and Mississippi, the index match combination that I'm referring to will in fact return the intersection. So in this case, 4,347. Okay, so let's go through this in two different examples. We will go through an example where we're hard coding in numbers for the right row, right column, and the intersection value. And then we will go over the individual parts for this particular activity. So, for example, let's say for the sake of the example, we want to retrieve the value in the first row, first column. So let's type in, and I'm going to go ahead and zoom in. Let's assume we want the first row, first column, and we're using an index function. The index function requires at least two parameters, the third being optional. So the array is the highlighted field that I originally highlighted. It's all of the data fields inside of this table, which is bound by column headings and row headings. Let's go ahead and highlight this entire table. Like I said, it's a bit lengthy. Once we have selected that entire array, we can go back up to the formula and type a column and type a comma. You'll notice that the row number is highlighted as an available parameter. Let's go ahead and go up to the very top of our spreadsheet and simply reference the row number that we manually entered, which is B1 in this case, which is a value of 1. Now the optional reference here in the formula, which is column number. In this case, we're going to reference the 1 from the column number and simply hit enter. The value that we're seeing is of row 1, column 1. So in this case, it's DIFFD product with Alabama. So we have returned a value of 7,317. So now let's experiment with a few other numbers. Let's say for the example, I enter row 5, column 3. So in this example, row 5 would be starting from here, 1, 2, 3, 4, 5. So we're talking about the TIGRIT row. And now we need to count over columns. So Alabama is 1, Texas 2, Nevada 3. So the intersection of these two parameters, 5, 3, would give us a value of 3,472. Okay, so that's fine and dandy. In order to demonstrate the power of this function or combining these functions, I'm actually going to copy the text here in cell A12. Let's copy this, and I'm going to list this as a product here in the cell E1. And I'm going to go ahead and copy Nevada as a reference here. Let's do a little bit of alignment here. So essentially what I'm asking for is to find the row of TIGRT in the row headers, and then find the correct column which corresponds to Nevada. We can actually do that with a match statement. Let's take a look. Match returns the relative position of an item in an array that matches a specified value in a specified order. Okay, let's hit match. The lookup value that I want to find is going to be equal to the text TIGRIT, comma. The lookup array will be an array or a range starting from the first row header, which in this case is DIFFD, all the way down to the very bottom. So let's go ahead and make that selection. And let's go ahead and put a comma. Now the next parameter is match type. You'll have to do a little bit of investigative research on this with the help function, but in general what we would like to return is an exact match, which exactly matches the text string. If it can't find that text string that we're looking for, it'll simply return an error. There are other options, for example, less than, which will find the largest value that is less than or equal to the lookup value. The lookup array must be placed in ascending order. The exact match that I'm referring to finds the first value that is exactly equal to the lookup value. Lookup array can be in any order. So to me, this is something I use 99% of the time when I'm using this strategy. I very rarely use the 1, which is less than, or the -1, which is greater than, which I'll go ahead and read that text as well. Finds the smallest value that is greater than or equal to the lookup value. Lookup array must be placed in descending order. So there are some applications of these two parameters that you can put in the formula, but in general we're looking up an exact match. So I'm going to go ahead and double click that. It'll place a 0 here. If you wanted the other ones, you could simply put the negative or positive 1. Let's hit our ending parenthesis and hit enter. And what we're actually showing here is exactly what we manually typed out here. We are returning a 5, which is telling me that this product location is in the 5th row. So 1, 2, 3, 4, 5. Okay, we can do the same thing with the state. So let's write that match. The lookup value now will be actually a reference to the state that we're interested, comma. Let's look up all these states, clear across the entire table, comma, and 0 for exact, ending parentheses, and hit enter. Now what we're noticing here is we're getting a 3. That's because Nevada is in the 3rd column. So now if we were to implement the same kind of strategy that we did before, index what array, index this array, all of our data in the table except the headers for the rows and columns, comma, what row number should I return? I should return the 5, comma, what column number? I should return the 3rd column. Enter, and we have exactly what we have retrieved from the table in the first example. So what I'm suggesting is we can utilize these matching strategies in one single cell to return the value of 3,472, which is exactly what we wanted. So here we broke it down into 3 steps: the match for row, match for column, and then the index. We could simply double click this cell reference, highlight the formula, and integrate it directly into this formula. So wherever we're referencing F1, we can paste that formula in. Do a similar thing with F2, copy the formula inside the formula editing window and paste it here for F2. Enter. So I would definitely try that when you start out with an index match to make sure you're returning the right cell locations and the right value for that matter. So once you have mastered that, and it might take some practice, you should be able to write one statement rather than breaking it up into several steps. So let me show you what that looks like. And you might, of course, have to watch this video a few times to master this type of activity. So in cell E3, let's write the statement index. What are we going to index? We're going to index starting here B8, the entire table, not the column headings, not the row headings, the table value itself, all the way down to the bottom. I'm not using an absolute strategy because I don't plan to fill this formula down or to the right, so that's okay. We now need the row number, which is going to be based on that match. So what do we need to look up? Well, our table is separated in terms of product along the rows and states along the columns. So we need to find the right row, which would refer to looking up the product, TIGRIT. Let's go ahead and place a comma. The next parameter is a lookup array. So essentially we're asking ourselves, where do we want to look up this value at? We want to look up that value here, down through the rows, all the way to the bottom, which is A41, comma, match type, and we want an exact match, so let's go ahead and type a 0, parenthesis, comma. Now we're trying to find the right column reference, so we're going to use another match. Match, lookup value. In this case, we're going to look up a state because that's what defines our columns here. Look up Nevada, comma. Where do we want to look up Nevada? Well, it's going to be across these columns all the way to the end, P7, comma, match type 0, parenthesis to end the match, parenthesis to end the index, and hit enter. So now what we're displaying is the 3,472, which we exactly returned when we manually assigned the row and column number. Okay, so I'm going to erase these references here and go ahead and just practice writing the individual row, column, and intersect back here. So rather than manually typing out a 5, why don't we practice this match command? So equals match, lookup value will be E1, this particular product, comma, where do we want to look it up? We want to look it up amongst all the products, comma, match type 0. So that's going to in fact return a 5, but now this cell is dynamic. So if I change this product, and we'll do that here in a second, this reference will change. Let's look up the right column. Match, lookup value will be Nevada in this example, comma, lookup array. Where do we want to look up that state? In the state headers, all the way to the end, comma, and match type is 0, almost always. So now we have a dynamic reference to these particular cells, which are in gray. Okay, so that's all fine and dandy. For this particular combination of product and state, we have the sales volume. Let me just do a quick amount of formatting to get these looking the same. I'm going to decrease this. You don't have to, but it's just driving me nuts a little bit. Okay, so now let's say we want a different combination of product and state. Let me select the row heading BEAUTT, and I'm just going to simply copy this and paste it in here. Now, if we were looking up this particular product with Nevada, we're pulling in 4,754 because this particular product is in row 12 of the table. The column is 3. What if we were to change columns? Let's pick Florida. We'll paste it in here. So now the column reference is 10, which we are picking out the value 9,474. So the idea is that we can type any reference we want to here. Perhaps Utah. Now let's type in OLDTIMR, which is in row 22. Let's hit enter. And we're not finding a particular value for this. Well, why is that? Well, it's actually because I did something intentionally. The product is not going to be equal to a state. In other words, this product of Utah is not going to be in this field. Likewise, the state, old timer, is not going to be a state, so we're going to return an NA. So obviously what I meant to do is type out old timer and the product and Utah into the state. So I essentially wanted to throw an error just because I wanted to demonstrate that it has to be an exact match. In addition, if you're typing out these values, if I had Utah space, so I'm just going to add a space there, enter, it's also going to throw an NA. Why? Because this field that we're looking in only is Utah, UTAH, without any spaces. The value we typed in is Utah with a space, so they're not equal. A space actually does matter. So in this case, I wanted to go through a couple examples of how you might want to debug a formula if you do in fact have an error. So in summary, we demonstrated the use of index by supplying a particular row and column. We then later wrote a specific match statement looking up at the particular product in the table. And then we followed that with another match to look up a particular state. We combined the two formulas together into a single cell reference, which indexes a table, finds the correct row, and then the correct column to return the specific intersection of the value that you're after.